My name again is Carrie Thompson, and I'm with the U.S. Fish and Wildlife Service out of Sacramento. And I'm happy to announce our next plenary, Adapting Our Management and Decision Making. These talks will build on the talks we've heard this morning. Dr. Stephen Schneider will be kicking us off this morning with a talk on adaptation strategies in the face of uncertainty, and will be followed by some local perspectives and specific applications of different adaptive management approaches. Dr. Stephen Schneider is the Melvin and Joan Lane Professor for Interdisciplinary Environmental Studies, Professor of Biological Sciences, and a Senior Fellow in the Woods Institute for the Environment at Stanford University. He has served as an NCAR scientist from 1973 through 1996, where he co-founded the Climate Project. Please join me in welcoming Dr. Stephen Schneider.
Thanks very much for the introduction, and I appreciate everybody turning out to discuss this happy topic. We'll have another one of these really pleasing discussions. Okay, actually the title that you just gave me I like better than the title that I thought I was given, because, you know, expecting unimaginable surprises. It reminds me when in the heat waves in 1988 and the Congress was interested in climate policy, in particular Senators Gore and Wirth and Bradley. So I was testifying with a number of people on these issues, and we were warning about surprises when you take a nonlinear system like the climate and you force it very rapidly. So Senator Bradley says, well, what are some of the surprises that you're thinking about? So of course we said the usual, well, a surprise, sir, is, you know, something you really don't know. And he said, come on, you guys got ideas. And he managed to pull out of us, well, let's see, there's possibility of rapid melting of ice sheets. There's possibility of changes in Gulf Stream, of species extinction. So he was right, all those little speculations in the back of the mind that scientists who are always careful not to say too many things that we're not sure of, a lot of them are happening. So the reason that the problem is becoming more credible as a political action item now is because for those of us who've been talking about this since the 70s, back then it was largely theoretical with a little bit of empirical backup, and now nature, unfortunately, has been cooperating with theory, and most of what was predicted is starting to happen, either faster or slower, of course, as you'd expect, and that creates a sea change in political willingness, although that was interrupted for a while for the obvious reason that we've seen cartoons on. Okay, so let's start out with a poll, because I always like to find out how effective I am. So we'll ask this now and we'll ask this later. And I ask the question that I'm asked by every press interviewer I've ever been to, and by pretty much everybody from community groups to graduate students and high schoolers, even elementary schools, right on down to congressional committees. And oh, good, you're awake, just testing. And the question is the science of global warming settled? So we'll do a poll. How many of you think the science is settled? Easy group. How many think, don't protest yet, how many think it's not settled? All right, how many think it's a stupid question? That's right. There we go. Because when you're dealing with complex system science, there are well-established components, and we've seen several from previous speakers. It's unequivocal that the Earth is warming. That's based upon thermometers, melting glaciers, plants and animals moving around, sea levels rising. It's very likely that humans are responsible for most of that in the last 30 years, 40 years. How do we know that? Well, because Mother Nature is a perverse lady, and she gives us climate change, and she doesn't say how much is due to her and how much is due to us. So in order to do that, I'm sorry, empiricists, you've got to have a theory, because you cannot do that empirically alone. So you take a mathematical model, you drive it only by natural forces like changes in the sun and volcanic eruptions and so forth. and then you predict what should have happened from 1950 to now. Now you correlate that with what actually happened, and it turns out you get a very low correlation coefficient. And in fact, if you use those to predict what happened to phenology, as Terry and I and others have done, you also get a pretty low correlation. Now you drive the model with anthropogenic forces, CO2, aerosols, which cool, the hazes, and you get a much higher correlation. Still doesn't explain 50% of the variance, but it's a much higher correlation. It's obvious that anthropogenic forcing has to be part of the show. The probability of chance in this is very low. Then you force the same models with the combination of natural and anthropogenic, and you get an even higher correlation. So it gets to the point that these fingerprints are pretty difficult to turn down. So when somebody says, well, it's just coincidence that the carbon dioxide's been going up and other greenhouse gases and temperature, they're right. Because if we were completely ignorant, you know, there's a 50% chance it could have been warming or it could have been cooling. There's a 50% chance that CO2 could have been going up or going down. So just looking at that alone doesn't give you high confidence. That's why we do fingerprints. We look at what warms up more, the middle of continents or the middle of oceans. Well, the climate models say if things are driven the way we believe them to be, then you get a fingerprint. Middle of continents warm up more than middle of oceans. Did that happen? Indeed it did. Probability of chance, again, 50% it could have gone up, 50% down, 50% the oceans could have gone up less or more. So you have a 25% chance it's just random. What else do the models predict? Lower latitudes warm up less than higher latitudes in continents. Did that happen? Yes. Another one of those 25s. By the time you put them all together, it's very likely, said IPCC, which means more than 9 out of 10, it's even higher probability than that the last part was due to human activities, because you can't explain these multiple fingerprints, which required the theory of bringing a model into it, but you use empiricism to check. So that's sort of how it works and how these groups try to operate when they make these comments. And there are people who say, but there isn't a consensus, meaning everybody doesn't agree. Well, everybody doesn't agree. But what IPCC does is it does not agree that there's a consensus on how many meters the sea level will rise, but it agrees as a consensus on the confidence that we can make in the degree to which it is. So the consensus is over confidence, not over outcome. And again, that's something that's very difficult to get across politically, because everything I've just told you is impossible to cram into a 10-second soundbite, which is all you get on the evening news. You can get it into 5-minute congressional testimony, but it's hard. All right, so science has well-established components. It has competing explanations. I'll show you examples of both. And it has speculative components. And don't let anyone tell you, although they'll tell you in the Wall Street Journal every week, that we can show where the mainstream view is falsified by a new piece of data. It doesn't falsify anything. Falsification is a 19th century concept. So here is a liquid. And I can give it a test. I think it's acid. So I have a hypothesis. Now I can get a piece of litmus paper and I can falsify or prove the hypothesis. Well, when you have binary outcomes where that's the case, then it's easy. But when you're talking about a multiply complex system where you don't even know if the data's collected right, it takes 20 years to figure out that the satellite which said it wasn't warming was wrong, not because the satellite was wrong, but the guys who were doing it did it wrong, and it took a community 20 to 25 years to figure that out. You don't falsify. What you do is you accumulate preponderance of evidence, and that's exactly what the assessments do, and sometimes that gets hard to convey out there when you're in the soundbite world of end of the world, deep ecology type versus good for you, enterprise institute type. Two lowest probability outcomes get most of the attention, and then everybody goes away confused because they all have PhDs. And I promise you that there are people who are very well paid to create exactly that confusion. And they prey on the media concept of balance, get the Democrat, get the Republican, perfectly appropriate in covering politics, absolute disastrous paradigm in covering complex science, because very rarely is it bipolar. Maybe some of the people are, but not the outcomes, and the smartest ones. And the outcome, and the big problem is that most of what we do has multiple outcomes with assigned confidences and probabilities. So, and if people can't get that, we have a big problem, because I worry more in some ways about whether democracy can survive complexity, because if people do not understand these problems, they don't give the political signals necessary to get the resources that we heard in the earlier talks to solve them. Which brings up one more point. Several people mentioned economic crisis. Well, that's a good news, bad news story from the environment point of view. The good news, did you realize it was good news, is that when Ellie mentioned that we have had set records, we indeed have. 2008 will not be a record CO2 emission. 2009 will probably be below trend. Because what drives emissions is population times affluence times technology. So we have to do a lot on that's old Ehrlich Holdren stuff, you know, from 1970. And what we can do is we can change technology, and we are, and that requires policy. But when there's a temporary down blip in affluence, there's a down blip in use. Don't let anybody tell you, oh, the problem's over, we stopped growing. Because almost every politician from the left to the right wants to get this recession fixed. The question is, it's an opportunity to fix it right, not to fix it by business as usual. And that's where we're going to have to be vigilant to see that that happens. And the reason that there's good news in this is that in the process of reconstructing the economy, we don't want to reconstruct it with coal burning and rape and scrape. And that means that we have to sit there and say it's provided us an opportunity to break the paradigm of the past and go forward. And at the same time, we might even get a little extra time, because when the economy slows down, so do the assaults on nature. So we have to see to it that what we rebuild is rebuilt with the right way to do it. And all of that's easy to say. And those of us who've been on the front lines of this for 35 years know that it's hard. But when you get the stars to align and you get the right people in office, at the same time you get this sort of publicly palpable event of the economic crisis, here's a real opportunity. But there will be forces of regression that will be saying, until the economic crisis is solved, we can't worry about things like emissions. So what we have to do is turn it around and say, this is the perfect time to actually fix that problem. So you've got to be all part of that. So anyhow, that's system science. What do we know for sure, well established? Well, that greenhouse gases like CO2, methane, and nitrous oxide, which were relatively stable for our warm interglacial period of the last 10,000 years, are all, quote, hockey sticks. They all went up after the Industrial Revolution. The inserts show you that. We have absolutely no doubt that they're a result of more people demanding higher standards of living and using cheapest available technology to do it. So the real question, the philosophical question is, as we improve people's quality of life, and I'm not going to deny that technology and organization improve quality of life, the question is, if we continue to do more of the same with the same techniques, do we continue to improve quality of life when you start getting these side effects which start to threaten the very quality of life improvement that was brought about by development? And now you have a poor set of poor countries that are a factor of 5 to 10 per capita less emitting or less rich than we are, and they say, wait a minute, you can't tell us to stop because you didn't stop in the Victorian Industrial Revolution. And then we say, oh, but you have 5 times the people we do. They say you have 5 times the affluence we do, and then you end up with all the fingers pointing around the room, and it's not always the happy finger, and it is definitely a mess. So what we've got to do is, this is a hard thing. We have to actually replace the C word that all the politicians like, competitiveness, and our economist friends, with the other C word, cooperation. And because if we don't have cooperative strategies, we're going to triple to quadruple CO2. And as we heard, that is not going to be good for virtually any system. And what are we going to do? Wait for the catastrophes and then try to scream back off the overshoot peak? Probably. But we have to try to make that peak lower and sooner. And that's what I view my job is, to try to make the bad stuff less bad. And I don't get hung up on how much we should be having emissions in 2020, because it's an impossible dream. You're not going to rewrite the economy, and you're not going to prematurely retire coal-burning power plants before their economic lifetime by 2020. So I wish my environmental friends would get off this 20% cut by 2020. It's not going to happen. What we have to do is make massive investments between now and 2020 so it can happen after 2020. So get off the numbers and get on the investments, because that's what will make the difference in the world. And I anger my friends when I say this, but we're not going to get credible when we advocate something which can't happen. And when it doesn't happen, believe me, Google will still exist in 10 years, and they will be Googling us and reminding us that we blew our forecast. And I get that from 30 years ago, even before there was Google. So we really have to be careful. All right. Global warming is happening now. IPCC used an unauthorized word from its guidance, unequivocal. They're supposed to have said exceptionally unlikely, but okay, it's unequivocal. That means it's beyond a reasonable doubt in the sense of a criminal trial, and it's for the reasons I said. And there is the unequivocal part. Do I have yeah, I do have a cursor. See, this is up here. This is the 0.75 degrees that Terry and Ellie talked about. And I think Richard may have too. This is the rise in sea level. This is decreasing snow cover in the northern hemisphere over that period. And if you drew a line through that, it's very noisy, but it's a clear trend that is statistically significant if you do it. But I just want you to notice something, because this is part of the end of the world and good for you debate. People out there trained in advocacy are always optimizing client interest, as opposed to what we're supposed to do, which is to give you a really balanced picture. So there are those who say, well, from 1950 to 1970s, snow cover increased. The Earth was actually cooling a little bit, the northern hemisphere rather significantly. There were even people who talked about ice ages. I was one of them. But then 3 years later, I said, well, I was wrong. And that was 1974. So, we go way back. And I still have to listen to, brilliant pundits like George Will, saying, oh, Schneider is an environmentalist for all temperatures, cooling them, warming now, what a joke. And what I had to say to answer him was, imagine the doctor for a patient walking in the office with shaking, chills, and fever, makes the prediction that it's pneumonia, but happens to run the blood tests and do due diligence, and then discovers it's malaria, but stays with the original diagnosis to be politically consistent. That's the mentality of George Will. But in any case, the key is that's false, and you know what the next one is. Or you could sit there and do what some of my friends in deep ecology movements do, start from 1970 down to there, and my God, we're going to hell in a handbasket, everything's melting off. These are false trends. The first law of political science is that all politics is local, and my lemma is and short term. And the first law of climate science is that climate change is global and long term. So we have a mismatch where there's continuous misinterpretation of short-term fluctuations, either in the predicted direction or the anti-direction, which is why Terry did meta-analysis that looked across hundreds of species, because when 20% of them go the wrong way, it does not falsify the baseline. What it does is it gives you very high probability that the aggregate's doing what you expect. So we in science have to learn how to communicate that, because the trend is only significant over a long period of time. Now this is update. We have a couple of years of new data since IPCC. Whoa, look at that, went down from the old. This is Hanson's data from Goddard. If you looked at the Brit data, 98 was a little higher in that El Nino year than 2000, and I think 4, I've forgotten what it was. And then here's this year that was down. So last year when I testified to Science and Technology, one of the most important climate scientists in the world, Professor Rohrbacher, for those of you who know Congressman Rohrbacher, was a fisherman, by the way, from Orange County, was there, and he said, I falsified global warming because CO2 has been increasing since 98 and the temperatures are going down, therefore it's not warming. So of course I said, but Congressman, if we started in 92, and then we went up to here, we would be having this miserable time. That good, it changed itself telling me to stop. But these are false trends. But they get covered in the media, and all kinds of people are out there and they believe this nonsense. That's, again, short term, my district, that determines reality, as opposed to long term, large scale, which really determines reality. So we have that problem. Terry showed you this picture and already, and this was an outlier event. I've forgotten whether my European friends told me it was 3 sigma or 4 sigma. Outside, if you fit a bell curve into the blue, that is way, way out there. However, if you take the curve and you pull it to the right, somewhere between 2 and 4 degrees C, then this 1 in a 500-year event becomes 1 in 50, and then by the end of the century, 1 in 10. So that's the way we're going to feel warming. And the primary way when nonlinear systems like ecological systems or humans, which are also have our physiology that's nonlinear, are going to feel it is through a change in the probability of extremes. And that's where the coupling to the mean is so important. Ellie talked about that with sea level. That's absolutely right. So if you want to think about it in bell curve terms, you've got the old curve here, and what's back there on the left side was cold extremes, and what was out there on this right side of the old curve was hot extremes. Now you pull it to the right, and I'm not changing either the autocorrelation or the variance, but of course we could, and that's what we use models for, but nobody really trusts them a lot on that. You're going to expect to have a dramatic increase in the probability of known extremes and then completely unknown extremes like that Euro heat wave. And when we talk about unimaginable surprises, it's completely imaginable that we're going to have them, but what they are, we don't know yet. Because when you've not been, you have no experience out here in a very complex system, and therefore when you talk about resilience, you have to talk about resilience to factors that are unknown. And that's a pretty good reason. Could we not pull this quite so far to the right? And in order to do that, we'll have to talk about pulling far to the right the way we produce energy, use land, and have notions of consumption. And you're going to have to do that in a world where about 4/5 of the people believe they have not yet had enough consumption. And that is going to be a very interesting debate. So California's been the leader, and there we have, and this is very, very interdisciplinary. We have scientists and we have an actor. I mean, we have all different kinds of things. We have a mayor who may very well be a governor, you know, unless it's an attorney general. But, you know, we'll see. And then we have the scientists behind them. And he announced that day that, and the four of us back there, were on the climate advisory committee for the state, and they asked us, well, how much warming is dangerous? And we said, well, nobody knows that. Dangerous is a value judgment. Yeah, but come on, what would you not want? And we said a couple of degrees. You know, the EU is set 2 degrees above pre-industrial. Well, we're up 0.75. That's 1.25 C above now, and the probability of staying below that looks to me like 0. But let's try to, and then people say, oh God, everything is lost. No, it's not true. The world is not good at 1.8 degrees above pre-industrial, and the world doesn't come to an end at 2.2. What we have to argue is more systems are more severely hurt the more you add. So if you can't do 2, do 3. And don't get hung up on the numbers, because you'll end up getting so blinded and discouraged that you'll lose the energy that you need to try to lower it from what it otherwise would have been. And when we hit that peak, let's come screaming down by hoping we've invented our way out of the problem. And our problem is not only going to be to figure out what the climaxes are, but we have to figure out what happens in an overshoot scenario when we overshoot thresholds like acidity. How long can we hold out with that high amount before we finally get smart and come down somewhere in the middle to the late part of the century? I don't think we'll triple CO2. I think we'll get scared off by taking 2 million people out in an Asia megadelta city, and then we'll say, oh my God, what have we done in 2025? And then we'll start to do something, but we'll have the overshoot to deal with. So we not only scientifically have to deal with climaxes, with equilibria, we have to deal with a very, very fast transient, and everybody knows that means you have to have a dynamical model in a system that you're trying to struggle to understand in equilibrium. So, and again, we'll have to learn how to express that. Anyhow, the governor of California, why is that funny, right? The governor of California said we have to have an 80% reduction in emissions by 2050. The economist sitting on my left, who's a very good guy, Michael Hanneman over in Berkeley, and strongly believes that economic systems, if they don't include the value of damages, are simply frauds. That is not what they teach in a lot of business schools, and certainly not the dominant paradigm in the Office of Management and Budget. So we have cultural change to overcome there. Leaned in my ear and he said, oh my God, Steve, why didn't they ask us first? How the hell are we going to do that? And, well, we're going to try. And I said, you know, Michael, if we only get to 40%, that's a lot better than what we're doing now, which is growing. California has the lowest per capita emissions in the United States because it has rules for performance standards. Texas actually is not the highest, it's the second highest. The highest is Wyoming per capita, but that's not fair because when you divide by 0, you get a big number. So Texas, so why is Texas 50% higher than the US average and California half of the US average? Because, you know, we're one of these deep blue states and we believe that collective protection is a political value. They're a deep red state and they believe protecting entrepreneurial rights is a political value. I'm not arguing one is right or wrong, but you've got to deal with this very pluralistic set of values, and what the president's going to have to do is come up with national standards, because you cannot allow states to scofflaw out of their responsibility, but then they're going to be in there trying to weaken it. So we have to do all of that. What were the motivating issues? Well, people have already done it. I don't have to spend much time on it. Extreme events, Mike Massandrea and I, my colleague, we went to all the counties. We looked at all the data that we had and calculated the probability of a 3-day max heat wave, and then we calculated it with climate models that had low impact scenarios and higher impact scenarios, and every single one of them becomes much more frequent. Well, that's not a surprise, just like I said with the other one. Terry already showed you this picture, but just to show you why we worry, these are projections made using a lower emissions and a higher emissions model. Remember, there are 2 fans of uncertainty. Human behavior, how many people in the world, what standards of living, what technology. Second fan of uncertainty, response to the biogeophysical system. And that's what we call climate sensitivity. Both of them have about a factor of 3 uncertainty. You put them together, you get close to a factor of 6, even 9, but that depends where you want to use your statistical cutoffs. So we try to portray that, and the blues mean you keep your snow, the reds mean you lose it. So not only are we going to get a radical change in phenology, which is going to have major impacts on the delta, but it's going to lead to a lot of political argument about where does that water go? Should we continue 90 cents on the dollar subsidization to agriculture, or do we protect the species? And these things, which are already controversial, difficult political things, become even more stressed because climate is a threat multiplier. You know, and it changes the likelihood of that. And fires, most people are not killed by fire. Many, many, many more people are killed, morbidity and mortality, in the smoke plumes. Children go to the hospital with asthma, adults with emphysema. And if you can calculate it out and show that, and it probably won't affect marine ecosystems all that much. But it certainly is part of the story. And you increase ozone and smog with warmer weather, and that's not helped by smoke plumes. Now the single most important impact anybody will tell you about. Wine in California is really pretty climatically optimum for doing it. And of course, in the lower emission scenario, it starts, the cool coast gets improved. That is, you can grow the cabs instead of the Pinot Noirs. And when you get up to the high one, bad news. I mean, can you imagine if BC has to produce all the wine that we drink? I mean, they'll get better because all the vintners will move up there. But this is another reason California cares. And it's also part of what you have to look at. And this was beautifully covered in the first talk, so I won't talk about acidification. So what's the law of the land? Well, this was signed by President Bush the first, at the UN Framework Convention of Climate Change in Rio. And it commits the United States, because he signed it and the Senate ratified it, to stabilization of greenhouse gas concentrations in the atmosphere at a level that prevents, quote, dangerous anthropogenic interference in the climate system. Now, of course, they didn't define that. But they gave us some guidelines within a time frame sufficient. They understood that the rate of change also matters to impact. The longer you have to adjust, the more time both natural systems and human systems can adapt. The more rapidly it occurs and the less you have capacity to forecast, the harder it gets. And they said to allow ecosystems to adapt naturally to climate change, and that's what most of you do, to ensure that food production is not threatened and enable economic development to proceed in a sustainable manner. That's pretty good, not bad for politicians and diplomats. But they didn't tell us what the level was. They came to us in IPCC and they said, well, you're the experts. Is 1.5, 2, 3, what's the level that climate is dangerous? And we said, guys, dangerous is an acceptability judgment. That's your job. So we kicked this football around for a while, and finally we made a deal with them, and we said, we'll give you the key vulnerabilities. will tell you the risk. Remember what risk is? Probability times consequence. But what to do about that is risk management, which many of you are involved in. That's making value judgments about weighing off political incommensurates. And when we talk about, so what is vulnerability, which is what it's exposure to the elements. In this case, it could be land use, as one of the questioners said earlier. In this case, we're talking about climate change, sea level rise, sensitivity. If you live in a very steep coast, you're not so sensitive to sea level rise. If you live in a very flat plain, you're in the Gulf Coast in North Carolina, places like that, you're much more sensitive to small changes. Okay, and then adaptive capacity. And adaptive capacity is a function of your development state and your knowledge base. So therefore, you have it all mixed up, and I'll end with pointing out that exposure is basically climate dynamics, physics and chemistry, and some biology. Sensitivity is a mix of natural and social sciences with that, and adaptation is largely social issues, except for ecosystems, of the kind of issues that were talked about earlier, and that what we have to do is take a look, and my chapter in IPCC, Chapter 19, Key Vulnerabilities, was to come up with criteria that could help people make these decisions. And so what would DAI's dangerous anthropogenic interference, key impacts and vulnerabilities, mitigation adaptation strategies, avoiding irreversibilities, priorities for research. None of those came from our committee. They were given to us by 120 governments, including the United States in 2004. And therefore, that's what political world wants. How do you define them? Criteria: magnitude, timing, irreversibility, adaptation potential, distribution, likelihood, and importance. Those are the elements which determine how many people, what stakeholders, and where wish to rank the relative importance of incommensurate things. And I'll end with this last slide. No single metric can adequately capture the diversity of key vulnerabilities and determine their ranking. We in science have a job, risk assessment. But the job of the stakeholders and the management and the government is making the value judgments about not risk assessment, risk management, but we have to be partners with them. Otherwise, the entire enterprise will not work very well. Thank you for listening.
Thank you, Dr. Schneider. Do we have any questions for our humble and previously unannounced Nobel laureate? Omitted that from his bio.
Well, you know, Terry also, and when people introduce me as a Nobel laureate, I remind them that there's been 2,000 significant jobs in the IPCC. I've probably done about 9 of them. So that gives me 1 shot in 200. So it's about, you know, 1/4%. So don't overinflate it. All right.
So any questions for this plain old guy?
That's right.
Please state your name and affiliation.
I'm Rick Champion from the U.S. Geological Survey. Going back to one of your slides where you were talking about short-term, long-term, and the arrows going up, how much of that fluctuation would you attribute to things like measurement or modeling error, and how much might you attribute to some underlying, this slide, yes, to
Right.
some underlying climate cycle that has not been explained?
It could be both. The one thing that's completely clear when anybody asks what causes climate change is there's unpredictable weather variability, and that's a component. And therefore, that translates itself into unpredictable fluctuations in the global mean temperature. You can estimate it from models. You can estimate it from looking at very long-term records. We think the number is on the order of 1/10 of a degree, maximum 2/10 of a degree C per decade. Then there is natural forces or cycles that could be driven by volcanism, by sunspot cycles, which have, you know, not just 11-year periods, but others. And we know that the sunspot cycle causes changes in energy output from the sun, but it's a small fraction of the greenhouse forcing. So those people who say, like the Wall Street Journal editorial writers and Senator Inhofe, who say it's all caused by the sun, have some little problem to explain, which is how is a quarter of the watts per square meter of the total forcing that's come from the sun working, but then the 4 times that comes from greenhouse gases not working. I always thought all watts per square meter were created equal, whether they came from the sun or from heat trapping, but they don't because it doesn't fit their client's interest. So there are internal cycles that could also take place that are not just interannual fluctuations, but energy exchanges between the deep reservoirs, like the deep oceans, the upper. So the deep oceans have, as Richard said, they have hundreds of years timescales. Upper oceans have decade timescales. The atmosphere itself has monthly timescales. So glaciers can be thousands of years to less than that, depending where they are. All of these systems, which look like this as this multiply complex millions of interactions, actually, if you boil it down into 4 systems, you've got 4 systems with different timescales. Chaos freaks will say, oh, that's a perfect thing for chaotic dynamics. So there certainly could be what you said in there. But they would have very different fingerprints. And that's why we sit and we use the models to predict the regional distribution. For example, it would be very hard to argue that there was a long-term cycle where the stratosphere cools and the lower atmosphere warms. The only fingerprint that we know of that could do that would be human emissions, because that decreases the ozone, which cools the stratosphere in the high latitudes, and greenhouse gases would cool it everywhere. So the prediction is stratosphere cools, lower atmosphere warms. Now, if the sun did it, it would warm everything, upper, medium, lower. What happened? In the last 50 years, stratosphere cooled, lower atmosphere warmed. Again, 25% chance. That's random if we knew nothing, but you put that fingerprint together with the others, and I don't think you have a very good case for natural long-term fluctuations being responsible for the whole show. I wouldn't rule out half the show, but I don't see how the fingerprint evidence, which is very well established, can simply be refuted because there are other components of the system. You have to separate out the fraction of the variance attributable to each.
Another question?
Yeah, Brian Check with Fish and Wildlife Service. Do you think that there is such a thing as green growth, or would it be better to describe it as lesser shades of brown growth? And should we be helping the polity to recognize that the distinction between, the hope for a green growth, or to recognize that actually there are lesser shades of brown growth?
Well, obviously, we want to have a world where people have a decent standard of living, where there's good nutrition and health and so forth. And we like mobility. We like to travel around the world. It probably lowers some tensions when we know people in various places, so that you certainly can buy some of what the economists say about the need to expand the economy. On the other hand, I equally agree that there's a downside to that when you let it go too far. I remember the old iPad from Paul and John, right? Impacts population, affluence times technology. And if your paradigm is endless growth, both in population and affluence, the only term you've got left is to get the technology term done. But that can't go on indefinitely. It is completely true that you cannot continue indefinitely on the path that we are on. So we're going to have overshoots. We're going to have overshoots in emissions. We're going to have overshoots in population. And you can't have overshoots in extinction. So our job is going to be to try to navigate this overshoot, to try to convince people to get off growthomania toward more sustainable, steady states. But you're not going to do that by prematurely retiring coal-burning power plants that haven't had their capital lifetime. You're not going to stop the momentum of population in the developing world, though it's getting better. And what we're going to have to do is everything we can conceivably do to bring the consciousness about the dangers that what we used to use, the technological, and organizational means to improve our quality of life, are now threatening to reduce that very quality of life. So we have to protect the commons at the same time we have to deal in fairness with those who haven't had their shot yet. That is the job of the next 2 generations. And not that many of our colleagues out there walking the streets even know that's the job. So we have a long way to go to get people to understand it. And I out of resignation say, well, let's move first to technology, because we've got to start A, lowering the total impact, and B, we have to start changing the mindset. We have a historic opportunity to do that right now through the combination of the leadership that we have and the economic crisis. And if we navigate it right, we'll make that peak of the overshoot lower and sooner. If we navigate it wrong, we'll use business as usual techniques and then indelibly commit to even worse situation. It's going to be up to us. The future, I don't have the crystal ball on it, but we've got to work our tails off to try to see to it that people understand that we have an option. Let's go for it.
We can take one quick one as I transition to the next speaker.
And I'll try to be quick in my response. You laugh. You've already figured me out. All right.
I'm David Graber with the National Park Service. Dr. Schneider, I'm going to ask you a political question because you've been swinging with the policymakers and the political.
I would never take on a political question.
Oh, you will. And the question is, in your opinion, do you think it's going to take one or more environmental catastrophes that can be blamed on climate change to sort of push both public opinion and the policymakers in the direction that we need them to move? Or do you think we can simply do it with rational thinking, slides, and more meetings?
Yeah, well, if we did a poll of the nature-centric versus anthropocentric value system of this audience relative to, say, a similar group in Kansas, guess what we'd get? We would get no statistical overlap except at the tails of the thing. You've got a large set, and remember I contrasted California and Texas, and they're very, very different values. And values are deeply embedded. Margaret Mead told me in 1974, when I was a very frustrated puppy thinking about exactly these kinds of things, as a 29-year-old. In fact, John Holdren was just appointed to be the science advisor to President Obama, and I were the two people there fighting against the forces of darkness for expansion, indefinite expansion, and all that. And so I expressed this frustration to her, and she said, Steve, you don't understand anything. You don't know any anthropology. Ideas travel at the speed of transportation. They're everywhere and immediately. But you're talking about cultural change. Cultural change moves at the speed of generations. So we're now one generation or so, maybe two, into environmental issues, and there's already a big consciousness change, so we can celebrate that. But we still have a long way more to go. And I don't think that it will happen without a change in consciousness from our giving, not speeches to each other. That's helpful to make sure that what we say is true so that we don't give ammunition to our enemies to say that what we're saying scientifically is wrong. But I also think it's going to take emotionally tangible symbols, which include fires in the West, melting Arctics, drowning polar bears, and intensified hurricanes. All of that's happening, by the way. It's very hard to argue what fraction of that, is fluctuation, what fraction of that is us. So I think it's going to be both. I personally believe that there will probably be some mega disasters, probably in Asia, that will tip them toward a radical switch away from their expansion in coal. So it's both. But the key is that when these things happen, Katrina happened on the watch of you-know-who, and he went around saying natural disaster. Well, nobody knows whether the half-degree warmer Gulf of Mexico, which is almost certainly attributable to global warming, was responsible for the storm surge. Will be 3 inches or 3 feet? We don't know that. We'll never know that. If it was 3 inches, it didn't make much difference. If it was 3 feet, it probably knocked out New Orleans. All you can do is look at that statistically over time and aggregate it, and they're building up, and they're building up, and the data is pointing in that direction. These catastrophes, as they occur in the direction forecast, enhances your credibility. Remember what I said, nature's cooperating with theory. Unfortunately, we have to perform the experiment on laboratory Earth with us and the rest of the living creatures along for the ride to get anybody's attention. It's happening, and what I'm hoping is that we can use what's happened so far as enough ammunition to move forward and not have to have bigger and more. We'll see.